Again, this is a snowball, so we are snowballing at this point. Our snowball is getting pretty big. We are just packing on new stuff on top of old stuff. So a lot of this you should be able to do at least part of the way, and then we're extending it just a little bit of new stuff here. So number one, we should definitely know how to do. First 12 terms of the sequence of perfect squares. Jasmine, what makes a number a perfect square? Sort of. So when you multiply a number by itself, you get a perfect square out. So here we're going to multiply 1 through 12 by itself, and then we'll get the answer, the perfect square out. So 1 squared is 1, 2 squared, 4, 3 squared, 9, 4 squared, 16, 5, 25, 6, 36, 7, 49, 8, 64, 9, 81, 10, 100, 11, 121, and 12. 144. If you don't know those that fast, you need to, for sure. Do you need a pencil? Yeah. They're in the cup behind you. If you don't know your perfect squares, we've been doing that for about 3 weeks now. Very soon, we're going to start having quizzes on your perfect squares, and you will have to take that quiz every single day until you get all of them right. So definitely be memorizing your perfect squares. We do that for problems like number 2, where we have 13 plus the square root of 162. We need to simplify the square root of 162 first by finding its largest perfect square factor. So I'm going to find the factors of 162. If we stumble upon a perfect square on the right side, remember my right side are my largest numbers to my smallest numbers. So if I stumble upon a perfect square on the right side, that's going to be the largest perfect square factor, and you need to tell me to stop when I get there. So this is going to be 1 and 162. And then if we divide by 2, you can think of it like 160 divided by 2 is 80. 2 divided by 2 is 1. Next for 3, stop, why? 81 is what? Yeah, so 81 is a perfect square. It's going to be the largest perfect square factor that we get because our right side is largest to smallest. So we can simplify from here. 13 stays the same, and so does the plus sign. The square root of 162 is the same thing as the square root of 2 times the square root of 81. I know that when I multiply 2 times 81, I'm going to get that 162. And if I multiply 2 numbers inside a radical, it stays inside a radical. So here, Jake, do I know the square root of 2? No, why not? 2 is not a perfect square, so we're going to leave that as the square root of 2. And Stephen, what's the square root of 81? 9, good. So I'm going to multiply that by 9. If I'm multiplying a square root times a whole number, I'm going to put the whole number first. So I've got 13 plus whole number is 9, followed by the root of 2, the square root of 2. We talked about this yesterday, so this is the same idea as having 13 plus 9x. And Zachary, can I combine 13 and 9x here? No, why not? 9 has an x and 13 doesn't. Good. So same idea here. 9 has a square root of 2 attached to it, and 13 does not. So I cannot combine these two together. I cannot add 13 and 9 here because the 9 has the square root attached to it. So this is as simple as it gets. The real reason why we can't simplify here, it's the same idea, but 13 is a whole number, which is a rational number. And the square root of 2 is not a perfect square. So when we have the square root of 2, or we have 9 square roots of 2, that's going to be an irrational number. And we cannot add or subtract rational numbers with irrational numbers to simplify. So that stays the way that it is. Questions there? All right, so -3 is going to stay. minus, I'm going to simplify the square root of 125 by finding the factors of 125. Again, when I reach a perfect square on the right side, that's going to be the largest perfect square, and I can stop. So 125. 125 is odd, so it can't be divided by 2. 1 plus 2 is 3, plus 5 is 8. 8 is not divisible by 3, so 125 is not divisible by 3. 4, if I'm not divisible by 2, I can't be divided by 4. 5, I have to end in a 5 or a 0, which I do. And that's 5 and 25. And then if I'm not divisible by 2 or 3, I'm not divisible by 6. 7, my 7's, goodness. It's not divisible by 7, I don't think. Why? Good. Glad you stopped me before I really embarrassed myself with the 8s. So I don't need to keep going because 25 is a perfect square, and that's the largest one I'm going to get. So the square root of 125 is the same thing as the square root of 5 times the square root of 25. -3 minus stays the same. Kylie, do I know the square root of 5? No, because it's not a perfect square, so square root of 5 stays. And Alec, what's the square root of 25? 5, good. And anytime I multiply a radical with a whole number, my whole number goes in front. So I've got -3 minus 5 square roots of 5. Again, -3 is a rational number. It is a whole number. It makes sense. So we call that a rational number. The square root of 5 can only be approximated. It's a crazy decimal that is unpredictable and does not have an end. So that's going to be an irrational number. We cannot add rational numbers and irrational numbers together. So this is as simple as it gets. Questions so far? So last week, remember, for these problems, we were just doing the square root of numbers. Now we have those numbers in front. That is prepping you for something. So there's a reason that we're doing it this way. Yeah, we're building our snowball. Number 3, what's the new stuff this week? What have we added this week compared to last week? Okay, so we're evaluating the expression with the square root. The square root is the new part. And so that's adding to our snowball. We did have b squared minus 4ac last week. Now we got the square root. So let's start off with that. You're going to want to make your square root pretty long because we've got a lot of stuff that goes in there. The first thing I have is b squared. Jasmine, what's it mean to have b squared? Yeah, so b is being multiplied by itself. So I'm going to have my b here is 5. I'm going to put that in parentheses. If you're not putting it in parentheses, you're doing it wrong. And then square it. Minus 4. Zachary, what's happening between 4 and a here? Do what? So do you see 4 plus a? Nope, 4 minus a? Nope, 4 divided by a? Nope, so it has to be what? Okay, if I went through add, subtract, and divide, what's left? Multiplication. So I'm multiplying here. So I'm going to make sure I put parentheses to mean multiplying. Logan, what's a? 1/3. Good. And then Danielle, what's happening between a and c here? Yep. What are they doing? Which operation? Do we see a plus c? Nope. Do we see a minus c? Nope. Do we see a divided by c? Nope. So it's not add, subtract, or divide. What does it have to be? What's the only one left? Help her out. Multiplying. So I'm going to open another parentheses. And my c value is 9. I made such a big deal about that because I still had people on the assessment last week adding these numbers together. 4a and c are being multiplied together. So we don't need to be adding or subtracting here. They're all being multiplied. So I wanted to make sure that we knew that. Following PEMDAS here, Jake, what do I do first? Okay, what's the exponent?
5 squared.
5 squared. What's 5 squared? 25. So I did the 5 squared first. I think doing it in 2 steps yesterday kind of confused some people, so I'm just going to keep doing it 1 step at a time, even though it's going to take a little bit more room. Callum, what's next?
You multiply.
Multiply what?
A and C.
Sure, we can do that. This is a little bit different from what we've been doing, but notice 4A and C are all being multiplied together. You can choose which ones you multiply first as long as you keep consistency. And so I'm going to keep my 25 minus 4, and then I'm going to have a number here. What's 1/3 times 9? Or 1/3 of 9? 3. If we did this the way that we're used to, you do 1 times 9, which is 9, divide by 3 would be 3. Little tip, if you want to show your teacher where your square root ends, you can put a little hook on it. Kylie, what's next? We have to multiply -4 and 3, and what does that give me? -12, so I've got 25 minus 12. Alec, what's 25 minus 12? 13. And Logan, what are the factors of 13? Do 1 to 13? Is that it? Yeah, that's it. 13 is prime. So Jake, what's my largest perfect square there? Yeah, there is. 1. If my largest perfect square is 1, then I'm done. I'm simplified. That's as much as I can do. Questions so far? Ready for the next one? So I got the square root of b is 5 squared minus 4 times, Alec, what's a? -2. And then times again, Danielle, what's c? -3, good. And that's where my square root ends. Logan, what's first? Exponents, which one? The 2, so 5 to the 2 is 25. So I've got the square root of 25. I've still got -4 times -2 times -3. Stephen, what's next? Good, so multiply the -4 times the -2. Notice last time we did the last two first. Now we're doing the first two first. That's fine. So I've got 25. Stephen, what is -4 times -2? +8, and that's still being multiplied by -3. Kylie, what's +8 times -3? -24, so I've got 25 minus 24. What's that going to give me, anybody? The square root of 1. What's the square root of 1? 1. If you can simplify the square root, if what's underneath that square root turns into a perfect square and you can take the square root, absolutely take it. Tells a lot about your personality, I guess. So 4 is super important, so I want to take a break, kind of revisit 4 after we're a little bit more energized. 4 has a lot of moving parts, and so eventually you're just going to see this problem and you'll have to do all the parts on your own. But this is the first time that we're seeing it is this week, so hopefully it's getting easier throughout the week. That is my goal, is to make it easier for you throughout the week, but it's understandably still pretty difficult. F of x equals x squared minus 2x minus 8. Does anybody know what form that's in? Standard. So we're going to have 3 forms for quadratic equations, one being standard. Remember, with linear, we had 3 different forms. Linear, we had slope-intercept form, point-slope form, standard form. Kind of the same idea behind quadratics. We're going to have standard form. We're going to have factored form, which they're asking us to do in part A. And we're going to have vertex form later. You'll see that on your classwork 1 this week. If they're asking me to write this in factored form, what are usually the directions that tell me to do that? What do they usually ask you to do? If they want you to put it in factored form. Simplify is the other way. Factor. So usually when they ask us to simplify, they're giving us factors and we have to give them standard form. when it says factor, we're going the opposite way. So we're going to have f of x equals, since it starts with x squared, I can just go directly into my factors. So I'm going to set up my factors. Your factor parentheses should be right next to each other. There shouldn't be any space in between because these two things are being multiplied. And remember that the first term times the first term in your factors should be the first term in your equation. So what can I multiply together to get x squared? X and x. The last times the last should give you your last. So these two numbers should multiply to give me that 8. We'll figure out the signs later. But if I have 8, I need the factors of 8, and Stephen, go. 1 and 8, 2 and 4. Is that it? 4 and 2 would be repeating, so this is it. So I want these terms. So I've done the first times the first to give me the first. I've done the last times the last to give me the last. Now I want the inner term and the outer term that's going to be affected by this factor pair to give me this negative 2x. So Zachary, which pair do you think you want to pick if you want to get negative 2 in some way? 2 and 4. Again, we're waiting on our signs. I'm going to do my inner term, which is multiplying 2 times x, which would be 2x. My outer term would be x times 4, which is 4x. Jasmine, what would my signs be on 2x and 4x if I'm working to get this negative 2x? Okay, what about the 2? Good. So 4 is negative, 2 is positive. That's going to give me a negative 2x. So you need to follow this line. If my 4x is negative, I need to follow this line to the number and make that 4 negative. If my 2x is positive, I need to follow that line and go to the number and make that number positive. I know that it seems silly to do that right now, but it's going to catch you later when these problems get a little bit more complicated. Last check, what's a positive 2 times a negative 4? Negative 8, and that's what I wanted, so I'm good. Sometimes that sign on that last little term there will trip you up, and you need to definitely check that. So this is factored form. Those are my factors. That's factored form. Logan, what is f of x? It's really just y, so f of x is y. And if I'm finding the zeros, that's when y is 0. So all I'm going to do here is replace all of f of x, or really just y, with 0. Or I'm going to find out when my equation is equal to 0. Those are saying the same thing in different ways. So here, you're tempted to multiply out. Don't multiply back out if you're solving or finding the zeros, because that's just going to get you this complicated thing. And there's no way, no matter how hard you try, you can solve this for x. So we need to go ahead and work with our factors. X plus 2 and x minus 4 are being multiplied together to give us 0. And the only way I get 0 out of multiplying is if one of these things is 0. So I'm going to say, okay, what happens if x plus 2 is 0? And then on the other hand, well, what happens if x minus 4 is 0? Alec, how do I solve x plus 2 equals 0? Not quite. So think of what the opposite of x plus 2 would be. So we're going to subtract 2 from both sides. Good. So plus 2 minus 2 cancels, and I get x equals negative 2. Kylie, how would I do this other one? Add 4 to both sides, and I get x equals 4. Good. Both of those work. If I plugged in a negative 2 for both of these x's, the equation would equal 0. If I plugged in a 4 to both of these x's, the equation would equal 0. So both of those work. Logan, go ahead and give me my x-intercepts. Nice. I can tell you were paying attention yesterday. Remember, x-intercepts are when y is 0. So if negative 2 is my x, 0 is my y, that's going to be 1 point. Same thing on the other one. 4 is my x, 0 is my y. That's going to make my other point. Jake, what is the graph of a quadratic called?
A parabola.
Parabola, nice. So graph of a quadratic, remember that's a new word for us, is called a parabola. I visited this yesterday, but keep in mind, these two words look very similar. Your English teacher may or may not teach you this word, which is hyperbole. This is parabola. So when you go to English class, remember that this is pronounced differently than parabola, and your English teacher might yell at you for pronouncing this wrong. And then I'll definitely maybe giggle if you say parabole. I'm just not gonna lie about that. So parabolas, what do we know about parabolas? What shape are they? U shape. What else do we know about them? That's my and symbol. Okay, so maybe we'll get it once we graph the x-intercepts. Let's graph those. So that's going to be left 2, up 0, and then right 4, up 0. Those two are my x-intercepts. What should I graph now? The midpoint. What's the midpoint? So think about 4 plus a negative 2 and find the average. What's 4 plus negative 2? 4 plus negative 2 is 2. Divide by 2. And you get 1. So 1 is going to be 1, 0 is the midpoint there. Why do I need to find the midpoint? I know where to make the bend at. Why? What's there that makes it bend? Logan, did you just say it while I was talking? What happens at the midpoint? The AOS, the axis of symmetry. So these things are symmetric. So right smack dab in the middle of our x-intercepts, we're going to have that symmetry or the axis of symmetry. You should be used to graphing axis of symmetry from absolute value. Remember, we label it AOS, and then the other end, we write the equation. What would the equation be here? X equals, what's X equal here? 1. What happens at the axis of symmetry? What should be on there? So I'm going to erase this because that might confuse us. The vertex. And if I know the vertex has to be on the axis of symmetry, then part of the vertex has to be what? Remember, the vertex is a point. It has to start with 1 because it's a point and points are x comma y, and I know my x here is 1. So I'm going to use the fact that I know that x equals 1, and I'm going to plug it into my very original equation all the way at the top. F of x equals x squared minus 2x minus 8. If I have an x, I can get a y. If my x is 1, I'm actually just finding f of 1, which means everywhere there's an x, I'm going to put a 1. So x squared means I'm going to have a 1 squared minus 2. There's an x, so I'm going to multiply by 1 minus 8. This is called evaluating, and anytime I evaluate, I go in the order of PEMDAS. F of 1 stays the same, so that's just me naming what I'm doing. Stephen, what's first? Think PEMDAS. Exponent, which exponent? Yeah, so 1 to the second power, what's 1 squared? 1. I still have minus 2 times 1, minus 8. What's next, Zachary? Think PEMDAS. So what's this? That's subtracting, right?
Yeah.
And this is subtracting. What are these two doing? They're pushed together. So they're being multiplied. Which one comes first, multiplication or subtraction? Multiplication. So I'm going to do this negative 2 times 1 first. So 1, negative 2 times 1 is negative 2, and then minus 8. Here I've got 2 subtractions. I can just do the first one that comes to me. 1 minus 2 is -1. And then I'm going to do -1 minus 8, which is -9. So Kylie, if I'm finding my vertex, what was my x value? 1. What's my y value? 9. -9. Nice. So I'm going to use that and I'm going to graph that on my axis of symmetry. Does anybody remember how we get our pattern? Where we get that from? Remember, we want to look all the way back at our standard form, and we want to look at what it starts with. I start with an invisible 1 x squared. The 1, since that's positive, what does that mean? We're opening up. And the x squared will tell me how to graph this. So if I plug in 1, I've got 1 squared, which is 1, 2 squared, 4, 3 squared, 9, 4 squared, 16. Usually that's the most you can go. You probably will not have to graph 25. The first number that I squared tells me how far to go out. Since we are opening up, the second number tells me how far to go up. These are all from the vertex. So from the vertex, I'm going to go out 1 to the right and up 1, put a dot. And then I'm going to go from the vertex again, left 1, up 1, put a dot. You should start seeing a symmetrical image. From the vertex again, I'm going to go out 2 to the right and up 4. And then I'm going to go to the left 2 and up 4. If I go up, out 3, up 9, what do I hit? Yeah, our zeros are our x-intercepts. If we go out 3, up 9, so that part's done for me. I can go out 4, up 16. Notice my y value here is -9. What's -9 plus 16? Nope. Close. -9 plus 16. You're thinking plus 18. Nope, 7. So if I want to go up 16 from -9, I'm going to go up to +7 here. And again, from my vertex out to the left 4 and up all the way 16 to 7. If you can think about those numbers, you won't have to count squares. If you still have to count squares, that's okay. And we're going to draw a gentle U shape through this. Make sure it ends in arrows. Very similar to graphing absolute value, but it's a curve instead of a V shape.